I know it's been a while since I've posted. So today I'm going to show you how I managed to create a steering wheel, in fact mobile steering wheel for vehicles, to control the vehicle using the touch system on a mobile phone. So I think there's no any tutorial that cover how to create it, how to implement it. So I've looked everywhere on the internet to kind of get the source code of a steering wheel, how it is implemented. So I had to do it all by myself, and it turned out to be pretty simple. In this project, I have created a startup project. So this is just a control node, and as a child of control node, it's our touch screen button and our sprite. So our touch button has a texture of step base, and under the touch screen button we have our sprite, which is actually our steering wheel. So the first thing that you must make sure that is selected or checked on setting on general settings, and then input devices pointing. Then you must check this box on for emulate touch from mouse. What this do is that we can debug or test our steering wheel if it is working as we want on an PC or on this Windows device, or any us to test our game without exporting it to a mobile device. So that's it. So let me explain a bit about this script I've already written. So this is just basic control for this is just all this as this code that I write here is not relevant. It's just for controlling the screen. So this code that I've written here, it just control this the it's just configure our viewport. As you can see, if I'm resizing the viewport, and the steering wheel stays on one position, on a fixed position, as you can see. So we have our value here, exported variable here, star x percentage and star percentage y value. So as you can see, add an x. So this star x percentage determines the position in percentage of our steering wheel. For instance, if I put this to 80% here and restart, you can see it's on this corner, right here. So this basic code just control our position in percentage where we want to put our steering wheel. You can kind of understand this on your own. If you want to know how it's done, you can just look at the code and figure out how everything works. Yeah, let's get to the main part of this video, actually creating our steering wheel. So in this tutorial we are going to use mostly the dot product and the vectors. So in order to follow through along without any challenges, I recommend you watch these videos first that I'll put a link down. I'll put the link on the description so that you can first, before you watch this tutorial, to understand vectors and the dot product if you do not. Let's first off by writing our function step intro. Now the first thing that we need to do is to get the mouse vector. So maybe let's just say mouse position. One position will be get at viewport dot get mouse position. So we are getting the mouse position on our screen. So mouse let's say mouse position is equal to negative equal to square wheel dot position plus offset vector 2 dot 64. And then save. The reason why we are doing this mouse, the reason why we are subtracting the steering wheel position to from mouse position. So let me run this script so that we can explain better. Well, basically, in order to calculate our vector, so the vector is a line from origin or at the origin to a point. So we want our steering wheel to be the origin. So we are subtracting the distance of the steering wheel so that the steering wheel the mouse position will be relative to our steering wheel as an origin. Basically, that line of code just reset the mouse position to be relative to the origin so that we can calculate everything as it is. And then we added the half size of then we added a half dimension of our sprite, our steering wheel dimension, I think it's 128 by 128. Then we add the half so that this will be our center. So now this point here will act as our origin. So when we calculate our vector, the vector will calculate from here to our position of our mouse position. Now let's calculate. Now we want to let's just 80% of the x-axis. Let me just say 16. You know, let's rerun. So right now here we want to calculate the dot product of two vectors. As you can see, we currently don't have any vector, so we will create our own vector. It's just a normalized vector that will go from the origin point to a point here. It's just a vector pointing upwards, and we'll also, in order to calculate the dot product, we must have two vectors. So we will be comparing, basically the dot product compares how similar are two vectors. So we will use that to calculate our steering wheel. So our first vector is a normalized vector that just points upward. Another vector will be our position, a point from our mouse position to an origin, to a center of our sprite. There will be a vector like this, I guess, pointing up. Now that for this to work, our both vectors must be normalized. So let's write a function that will do that thing. A function that will calculate for us a dot product. I'm just calling it dot operation. It will take in as a first parameter vector 1. Then it will return a dot product for these two vectors. Now let me just test this out. Print. Our first parameter will be vector dot up. Remember, it must be normalized. Dot normalized. And our second vector will be mouse vector. Now our second vector will be mouse position, and then let's run this. Sorry. Let's just run this on our physics process. Now let's run our script. Okay. I don't know what's happening. It's returning a large number. I must done something wrong. I've done something wrong here. There's a bug of obviously. Yeah, the mouse position also must be normalized. Let's rerun this. As you can see, when two vectors are similar or close to similar, be equal, equal, equal. When one vector is 90 degrees from another vector, the value must be, it will be 0 or close to 0. It will be 0 exactly. And as the two vectors are facing different way, it will be -1, as you can see. And as we are going to, as our vector are similar, it will be value of equal to 1. That's it. Now we have a way to calculate the similarity of our vector. So as you can see, this side and this side, as we get close, as we get opposite. Now so yeah, we need to declare some variable, one variable here. Last let's just say previous dot product, then we'll just set it to 0 initially. Let's calculate our difference in dot. Let's just create a new variable for dot difference. Difference will be equal to last, equal to prev dot minus the current dot product dot op vector 2 dot up dot normalized. Let's just copy this. Update our previous dot to be the current dot. Save. Now let's print our dot different to see whether everything is working correctly. And let me just run this sim. As you can see, when I stand still, uh, the dot product is 0. That means that we are not moving anything. But see what happened when I try to rotate clockwise. Is it clockwise? Clockwise, it's adding something. When I move clockwise, it's becoming. When I move anti-clockwise, it's returning our negative value. But see what happens when I go to the other side. When I'm moving clockwise, anti-clockwise, it's giving me a positive different value. To calculate, we want a way to know which quadrant are we, so that we can invert our value, so that when we rotate along, it becomes, when we are moving and when we are rotating anti-clockwise, it stays negative, and when we are rotating clockwise, it stays positive. The dot difference stays positive. Now let's solve that problem. So in order to solve this problem, we are going to create 4 vectors, another 3 vectors. The one in order to solve this, we have to create a function that will tell us where our mouse. We have 4 quadrants where the yeah. Now let's introduce a variable called star rotation. Star rotation will be equal to 0, equal to 0, equal to 0. Then we will take our star rotation. So it will be equal to, let's say, plus equal dot different. That's it for now. And then let's make sure we rotate our steering wheel. We go here at our physics process to actually rotate our wheel. We're going to get a steering wheel and rotate our sprite to see visually when our steering wheel is rotating. Then we said rotation degrees equals to negative. Let's just use positive. Star rotation. Yeah, so we are going to write, we are going to rotate our script. We are going to use our sprite. We are just going to rotate our sprite when we are rotating our steering wheel. We're just going to rotate a sprite. Let's run this and see what happens. Now you can see, but it is not moving because the value of a steering wheel is 0 point something. So all we need to do is to multiply the star rotation here. to match the rotation of the steering wheel. Maybe let's just 80. 80 I think will be enough. Now you can see it rotates, but it's not rotating accurately. Yeah, now you can see when we rotate in this side, it's rotating without any problems, but as we go to the other side, the 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 the, the steering wheel rotate in the opposite direction, and again when come back the same thing. So we want to find a way. We want to find a way. So we need to solve this problem. So we want to find a way to calculate whether the mouse position is on the front of a steering wheel or on the other side of the steering wheel. So let's go ahead and do that. So the way we are going to solve this problem is by using vectors. As you can see at our Cartesian plane, we have our y-axis and our x-axis here. So we'll treat this as we have our first quadrant here, and our second quadrant, and our third quadrant, and our fourth quadrant. So we have to find a way to know to know the mouse vector where it falls on this quadrant. So the way we are going to do this is to introduce different vectors: vector up, vector right, vector left, and vector down. So depending on the mouse vector, each vector will calculate a dot product that will give us a different sign value depending on which the mouse vector is on. So let's write that function. Speed quadrant so in the speed quadrant, it will return the value. It will return the quadrant. It will return which quadrant it is in the current state. So now let's run this so that I can properly show what's going on. And then let's just write this logic. If A is equal to 1 and B is equal to -1 and C is equal to 1 and D is equal to -1, then we will return Then we'll return quadrant 1. If this is 2, we'll return quadrant 2. C must be negative and D must be 1, and this must be 1, this must be 1. And then we're going to use our speed quadrant on our, where's our function, on our steering controller. Remember, we'll introduce our variable sp equals to speed quadrant. Then we're done. If sp is equal to 1 or sp equals to 4, then we will use this. Then we will increment this with the positive diff else copy and paste. Then we will use the negative value. Now, as you can see, no, something is wrong. Let's see what the problem is. Speed control, it's only returning a value of 4. The problem is this mouse position. We must use the mouse position that has an offset. This mouse position right here. Yeah, let's just copy this line of code. Now we can rotate our steering wheel infinitely as far as we want to. Now, now, now we want our steering wheel value to be between 0.1 and 1, I think. Yeah. Now we have our nearly finished functioning steering wheel. This is perfect, I think. Now the next step to do, we want our steering wheel to only work while we are touching the cycle. You can see now it's just following our mouse. So let's make use of our button now. So for this we are going to use function input. So if event is input event screen touch, or event is only if these two conditions are true. We want to be we want to calculate we want to run our steering controller. Let's just get rid of this. Now you can see as I move, nothing happens. When I touch here, I can start rotating. And as you can see, we have a problem here. I release the button, the touch button, and then when I rotate, it quickly rotates into a one space. It quickly rotates. This is a bug, of course. So, and as you can see, it starts rotating the steering wheel while I'm not touching at the steering wheel directly, because it's using the other side of the function input screen drag. It's true. So let's get rid of that. So if our button is pressed, we will only want to run this, or it's on still drag. Now let's say if the wheel dot is pressed, then we want to run this code. As I see, I'm clicking outside the steering wheel. When I click directly to it, it will only respond to me. And now is a proper time to fix this bug when it does this. So all we need to do is to reset our, when you touch our steering wheel, we want to reset our last dot to be directly So we wanna use release button pressed, yeah, then connected, then again draw mouse vector, mouse position, equals to get viewport dot get mouse position, and then our mouse position will be equal to negative equals to farewell dot position plus vector 2 and our offset 64 by 64. Then previous dot will be equal to dot operation that should fix that bug that we have. So as you can see, when I click directly, nothing happens. I can now move. It seems to work correctly. Now we have to clamp the rotation so that it will rotate and stop, and it will be maximal to have a maximum 10, and then that's it. I think now you can see we can rotate it. We just rotated I don't know how many times, but it stacks. Yeah, it is reach its maximum. Maybe let's just say 4, so that it can rotate a bit less. Make full rotation twice or once. Yeah, now it's rotating a little bit less, reach the maximum, reach the end. Now I'm just going to show you a working version of this, or the project that I did earlier. Then so again, I will link source code on my description. I will provide a link for this source code in the links below. Let's run this project. As you can see, it works perfectly. So in order to connect this with so in order to set this up with a vehicle, all you need is to create a script, and you will do the acceleration, everything. So you will control the steering part with this input steer function. So as you can see here at the top at this line, so we are getting the parent, which it is our vehicle body, and the steering function. Then we assign the steering rotation divided by its clamp right here. Where is right here? So you can probably decrease this or reduce the value of here, so that you can have, so that the steering wheel can rotate less revolution, I think. Basically that's it. As you can see, to make a full turn, you only rotate once or twice, I don't know. So again, I will link this in the description. So if you don't understand, or you do not understand the tutorial, you can just copy the script and assign it or apply it and use it without even understanding what is going on. But I will be glad if you understand everything that I was speaking about. So go and read the script or improve it. I don't know. I certainly don't think I certainly know